All right, so hello everyone, and welcome to this week's SETS online webinar. My name is Shraddha Menon. Before we get started for today's session, we would like to thank a sponsorship from IAS, which allows us to offer all of these resources free of charge. Make sure that you check out our website for more info on upcoming events and meetings and to see everything available for the community. So today's talk is by Dr. Elizabeth Chamberlain, Assistant Professor at Wageningen University in the Netherlands. She completed a master's degree at Louisiana State University and then received a PhD in Earth and Environmental Sciences from Caillou University. She was also US National Science Foundation postdoctoral fellow at both the Columbia University and the Vanderbilt University. She specializes in optically stimulated luminescence dating and its application in river, coastal, and deltaic systems. Her ongoing research includes the evolution of the deltas and the coasts over the Holocene in response to variations in sea level, sediment supply, and human influence. In today's talk, she'll discuss the human landscape evolution of the Mississippi Delta from sediment dating and archaeological perspectives. With this, I hand over the forum to you, and I hope it's a very interesting talk. Thank you.
Thank you, and thanks to those of you who are attending or listening later at the recording. So in the background here, you can see the city of New Orleans, which is in Louisiana, USA, and it's posed here on the banks of the river, the Mississippi River. And give me just a second, I'm gonna make sure that my pointer is doing, or see if I can get my pointer to do the laser thing. There we go, okay. So here we are in the Mississippi Delta and on the banks of the Mississippi River. And New Orleans is a city that's surrounded by water. So the view on the top is looking at the city from the river, and the view on the bottom is looking at the city from the coast, from the wetlands between it and the Gulf of Mexico. And this brings a lot of resources. So you can see here's Mardi Gras. The resource richness of deltas is found worldwide, and you can see this population density map is showing, I've highlighted some deltas, certainly not comprehensive. But for example, here's the Rio Grande Delta, here's the Mississippi Delta. The Nile is really spectacular in terms of its population density compared to the surrounding landscape, and so on. So there's a lot of motivation for people to live in deltaic landscapes because of the resources that are abundant there. But there are also risks associated with this. And so here, for example, you can see during Hurricane Katrina in 2005, there was significant flooding of the Mississippi River and coast, and that affected New Orleans a lot. You could see large portions of the city were inundated. And these types of problems of flooding in deltas are not just in Louisiana. We are concerned with this worldwide also. So in this graph here from Liviu Giosan and colleagues, you can see we have sediment available on the y-axis and sediment needed to elevate the delta plane by 1 centimeter per year on the x-axis. It's a log scale. And this is the 1-to-1 line. And then the size, different deltas are shown as data points by their size. So these are smaller deltas, the bigger circles are bigger deltas. And you can see that some deltas are plotting above the 1-to-1 line, which indicates that they have enough sediment available to keep up with 1 centimeter per year of relative sea level rise. But a lot of the bigger deltas apparently don't. They're plotting below this 1-to-1 line. And so coasts and deltas worldwide are grappling with these issues of living with water. And you might be asking right now, well, okay, that's great, Liz, but this is SEDS online. This isn't climate online or anthropology online. So why are we talking about this? And for that, I want to refer to this quote from Michael Church, who wrote a really nice review article about the trajectory of geomorphology as a discipline. So he said, geomorphology is simultaneously developing in diverse directions. On one hand, it is becoming a more rigorous physical science. And on the other hand, it is becoming more concerned with human, social, and economic values, with environmental change, conservation ethics, and with the human impact on the environment, and issues of social justice and equity. And this is important to sedimentology for a couple of reasons. One, people are increasingly active as agents of landscape change, including in sedimentary systems. And second, part of our interest in studying sedimentary systems is to engineer them to be sustainable for human needs. And this is particularly important in coasts and deltas where there are so many people living and they're so directly impacted by environmental change. And this is also one of my personal interests. And so this is the topic that I'll be talking about today, and framed in the Mississippi Delta, and specifically looking at archaeological sites and what we've learned from working over there in archaeological archives for the past several years. We're interested in archaeological sites because these hold the only millennial timescale records of human adaptation to environmental change in North America. And so, for example, here you can see one of the types of sites that we work on. This is an earthen and shell mound, and it's pretty far toward the coast. You can see here's open water around it, here's wetlands. And I'll talk more about the mounds a little bit later. So this is the outline for the talk. We've discussed the motivation. Next, I'm going to talk about geology and specifically how the Mississippi Delta has grown over time and changed over time. And then we'll get into the landscape archaeology and looking at detailed investigations of 2 earthen mounds and insights into mounds from across the Delta lobe, and mounds as a means of fostering resilience. And then finally, a synthesis looking at land management and future outlooks. So we'll start with the geology section. And a little bit of background about the Mississippi Delta. Studying these types of issues there is really important because this is one of the places that's seen the most land loss in the world in recent years. So here you can see a photo showing an example of some of the land loss. This road has been closed because of land loss. And then this image is showing the projection for the future with land loss in red in the next 50 years under a high scenario. The rate of loss that's been experienced here over the last century is 45 square kilometers per year. So that's a lot. People also refer to it as a football field an hour, which is scary. But there's a plan to combat that. And part of that plan involves these sediment diversions or river diversions that you can see here. Let me get my cursor over to the right place. There we go. You can see those here in these brown circles. These are potential locations for sediment and water diversions in the Delta. And the idea here is to make engineered cuts in the artificial levees that are confining the Mississippi River. And this would let river water flow into the floodplain and marshes of the Delta, feed the marshes, and hopefully build some new land. So one question that we wanted to know was what rate of land building could be accomplished by the Mississippi River under natural conditions? And what does this look like in the stratigraphic record? And to work on this, I worked with Torbjörn Törnqvist at Tulane University and others, and we were supported by NSF and CPRA. And so we looked into the Holocene record of the Delta to understand this better and get a longer time scale estimate of land building here. So here's a slide showing the Mississippi catchment. It's draining about 40% of the continental United States that you can see here. And all that sediment and water is coming down to Louisiana to build the Delta, and has been for several thousand years or longer, depending on what space scale you're looking at. And the river has moved with time. So here, the river came down and it built the Teche Sub-Delta. And then the River of Ulster changed courses and built the St. Bernard Sub-Delta. And then back over here to build the Lafourche Sub-Delta. And then finally to its modern configuration past the city of New Orleans and down out the Birdfoot. So one thing that's really pretty about this landscape is you can see the past pathways of the river. For example, right here through the Lafourche Sub-Delta, this is an old river channel. And it's coming down and it splits into a couple of smaller channels. And we can see this because the river deposits sediment near its banks, and that increases the elevation. So we have this natural levee that's built up with time of higher elevation land near the river from flooding or crevasse splay activity. And people like to live on high elevation land. This is land that's used for agriculture, for industry in present day, for homes and communities. And so it shows up in the satellite image as this lighter green color, and it's easy to identify these paleo channels through the Delta as a result. some of our earliest knowledge that the river had moved with time, or knowledge of these lobe switching processes, comes from the archaeological record. And so here you can see an image showing different age archaeological sites plotted in the Mississippi Delta. And you can see the different age groups correspond to the different subdelta lobes, right? And this information is coming from ceramics type largely. So if you have ceramics at one archaeological site and you're able to do radiocarbon dating at that site, you know the age of it, and then you look at the motif or the pattern on those ceramics, you could say, oh, okay, well, ceramics that look like this are found in this one place at this time. And then if you find them somewhere else, you could say, well, this other site is probably about the same age, because ceramics motifs and patterns change just the way interior design patterns and preferences change today. And so we can look at this ceramics type to get a sense of the age, but this is a form of relative dating. Nonetheless, it's very important. And so even if you're not really excited about archaeology and really like fundamental sedimentology or other types of science better, this is a nice example of how the two work together and how archaeology and knowledge of human cultures can be a good tool for sedimentology. Coming back to the question of how this built land, we wanted to look at one of the old lobes of the Mississippi River to get a sense of its rates and patterns of land building. And so we chose the Lafourche Sub-Delta, that's the one here. And here you can see again its channel network, a trunk channel coming down, and then splitting into multiple smaller channels here at this apex. And we worked in the area below the apex, doing several cross sections that I'll talk about in more detail, both on the main channel by Lafourche that you see here, and on some of these smaller channels through here. We approached this using hand coring to obtain the stratigraphy. And so here you can see my friend Chris Esposito is doing a hand core. And most of these we did down to 10 to 12 meters max, sometimes shallower, but that captures the whole sequence of deposits from the Lafourche Sub-Delta. And what we found generalized here was pretty typical of a delta that's building into open water, so delta progradation into a shallow bay. At the base, we have muddy units indicated by green. Green is mud or fine grained sediment. And then here we have a laminated delta front that's overlying it. And so this layer starts to get deposited when the subdelta has turned on, when there's water and sediment coming down this river channel, but we're still a little offshore. We're not on land yet when this is being deposited. And that grades up and we get a mouth bar deposit that happens when the river has reached that point in time and it's discharging a lot of sand. And so the mouth bar builds up. It can be a couple meters thick in this case. It grades to sea level. And at that point, vegetation colonizes it. It becomes more fine grained. The river mouth moves seaward of the point that we're looking at. And we get overbank deposition through either crevasse plays or overbank flooding. And this creates, again, a finer grained package of sediment and one that we see thins coastward. And this is what this might look like in a borehole. We can identify the bay floor as muds with shells in it. The delta front is siltier and it has these laminations. Here's the mouth bar sand in red, and then the overbank unit, which may also have some plant remains in it. And for all the sedimentologists, here's our sediment from our fieldwork in real life. So here in this one, you can see the bay floor muds in the left. And here's a little shell fragment from Rangia cuneata, which is a brackish marine shell. And then here we have this laminated delta front where some coarser sediment has been kicked in by the river being active. And here's some mouth bar sand. You can see here, it's not as coarse as sands you might find in other settings, but it's coarse for the Mississippi Delta. And it transitions very abruptly into these overbank deposits, which are finer. This type of stratigraphy is also what we find in a growing delta today in a setting like the Mississippi, for example, the Wax Lake Delta that you can see here. So because the mouth bar is deposited right at the river mouth where it's meeting the sea, and because it's grading up to sea level, it serves as a really nice indicator for tracking the shoreline of the lobe. And by dating it with optically stimulated luminescence or OSL dating, we can get a sense of the time of when that was deposited, and that allows us to track progradation of the shoreline in this setting. Optically stimulated luminescence dating is the type of dating that I specialize in. And in short, this is looking at a signal that's stored, in this case, in quartz sand grains. And it's sensitive to light. So the signal accumulates when the grains are buried, and it's zeroed, or this clock is reset when they're exposed to sunlight. And so in this case, by OSL sampling and dating the mouth bar sands, we can get a sense of the time that they were buried, the time that they last saw light. And this is a proxy for when that piece of land formed. Here you can see Erna at the Netherlands Center for Luminescence Dating, where I work, and she's loading a wheel of samples for measurement. And you can see this red light is the type of light conditions we work in. It's similar to a photography darkroom where we use a wavelength of light that is safe for the signal that we're interested in. And the work that I'm showing today was done in collaboration with Jakob Wallinga, who's the director at the NCL, and Tony Raymond, who was at NCL and is now a professor in Cologne, Germany. These are the results that we got from composite of our different cross sections and from our chronology. So this is inland over here, this is upstream. And then on the right, we're downstream near the coast. And this is along Bayou Lafourche, so the main channel of the Lafourche Sub-Delta. And you can see here, this is the point where the delta splits into those multiple smaller channels, or the delta apex. Above that, we have different stratigraphy than below it. So above the delta apex, we see it's underlain by a peat deposit. And that indicates this region of the delta was already land. It was a wetland when Bayou Lafourche became active. Whereas below it, we have this progradational delta stratigraphy with the shelly bay floor muds at the base, the laminated delta front deposits, and then a couple meter thick mouthbar sand shown in red. And then you can see here the overbank deposits that tend to thin coastward. And we've also dated a lot of this. So these are ages from other studies, and these are the ages from the work that I'm showing today. These are OSL ages in 1,000 years, or Ka. So this first one is about 1,500 years right here. So that's telling us that the shoreline was at this position 1,500 years ago. And you can see that the ages get younger as we move coastward, right? Down to about 750 years at the coast. And so it gives us a sense of the time scale over which Lafourche was active, and also its growth rates. And when we put the information from all the cross sections together and look at it in plan form, this is what we get. So here's the delta apex, all the different channels coming down, the ages shown as an average of 2 OSL samples. And you can see if you go similar distances from the delta apex down these different channels, you get similar ages. So like down here is about 940, 920 years for both channels. And this showed us that the channels were coactive. They were all acting at the same time, and the delta prograded in a radial fashion. And it prograded, we found, at a linear rate, which is what this graph shows. So here we have distance on the x-axis from the delta apex and age in 1,000 years on the y-axis. So a really nice linear correlation there. So concluding, coactive channels with radial progradation, and that they were creating land at a rate of 6 to 8 square kilometers per year. And over the 1,000 years that Lafourche was active, that translates to 6,000 to 8,000 square kilometers of new land. But this is much smaller than that 45 square kilometers per year of land that I talked about earlier that's happened over the last century. And so that showed a couple of things. First, we concluded there's a human component to the modern land loss. And second, it suggests that large portions of the Mississippi Delta are unsustainable because the river cannot build land at the rate that it's being lost today, even under optimal conditions and even under the best management strategies. So that's a bummer. But there are good things that we can take away from this as well. So here again, we're seeing land loss in the Mississippi Delta, and this is land that has been lost. This is the land over the last 100 years, all highlighted in red. And I think it's sad to see so much land loss, but it also leads to the idea that we need inspiring solutions for coastal management in a setting like this and in other places worldwide. And also, you can see these white circles here are archaeological sites, prehistoric archaeological sites. that are sitting in this area that we've studied extensively. So our findings from this land growth study, because we got that nice linear rate of progradation and have a good sense of how this lobe built with time, we can estimate the time of land emergence at a given point within this 6,000 square kilometer area where land was built by growth into open water. And we looked in detail at two sites that I'm going to talk about a little bit from now. As we transition into this part of my talk with the archaeology stuff, I want to highlight my colleague Jair Mehta. So here you can see Jair in the field shot, and then also at his university. He's at Florida State University, where he's a professor in environmental anthropology. And Jair has a really nice website, a WordPress website that you can check out to learn more about his projects and the things that he does there. So he worked on a lot of this collaboratively with me, and these are his ideas too in this next section that I'll show. So one of the things we wanted to know was, how did prehistoric people adapt to live in this highly dynamic delta setting? And we looked into the mounds for this information, specifically the Grand Caillou Mound and the Elsley Mound, which we studied in detail. So here in the upper image, you can see the Grand Caillou Mound. And it is really hard to take a picture of a vegetated mound in the woods, but this is what we came up with. And I've outlined the mound to make it a little clearer for you. You can see it's a nice pyramid-shaped mound. It's about 6 meters tall, and it's in remarkably good condition. So that was nice for extracting information and for doing studies of it. And then we also have the Elsley Mound, which you can see in the lower panel. And this one is in less good condition. It's also outlined here. You can see it's only 1 meter tall, and it has this historic cemetery built into it. And this is a typical practice in South Louisiana because the water table here is really high. So we looked at these two mounds in detail, and you can see their location here in this DEM. Here's Bayou Grand Caillou, which is one of the distributaries of the Mississippi Delta, one of those smaller channels below the Delta apex. And the Grand Caillou Mound is located up here. The Elsley Mound is down here. And zooming into them, here's Grand Caillou Mound right here. The yellow dots are where we did boreholes. And here's the Elsley Mound. You can see they're both on the natural levee, on this area that's adjacent to the main channel that's been naturally elevated by river flooding or crevassing. And you can also see that they're on a place where this main channel is intersecting with a crevasse splay. So here, and then again here. This is a point where water has breached the natural levee, and we've had channelized flow into the floodplain. And so this has allowed even more elevation to accumulate through natural processes at both of these sites. We used a variety of tools to study the mounds. We looked at their stratigraphy with hand coring again. So here you can see a couple of examples of that. This is showing an auger that's recovered some muds and then a wood peat. We found a really nice wood peat at the base of the Grand Caillou Mound, and we were able to radiocarbon date this, and that gave us a sense of when the mound began to be constructed. And then within the mound, we saw these alternating layers of silt and clay that you can see here. And so that structure is probably part of what has contributed to the endurance of these features. Jair led excavations at the Grand Caillou Mound, and so here you can see one of the excavation pits that he's done. This lets us get a better look at the mound stratigraphy and also recover things like ceramics that we can use for absolute dating and for affiliating the mounds with a prehistoric culture. And then we also used optically stimulated luminescence dating, and this let us measure when the land below the mound, the natural land surface, when that formed and how that was active. And these are the results that we got at both mounds. One thing I want to point out is that these are two very different spatial scales. The horizontal scale is the same for both, but for the Elsley Mound, we're looking at 100 meters in this space versus this is a 5 meter bar. So this one's really showing the stratigraphy of the mound and zooming in on that, whereas the Elsley cross section is showing the mound's position on the landscape. So let's look at Elsley first. Here you can see we have this common delta stratigraphy that we saw elsewhere with the bay floor muds. And then here's the delta front, the silty laminated thing. And then we get a couple meters of mouthbar sand, and we've dated that to a little over 1,000 years here. So this is telling us that land emerged here 1,000 years ago as the delta was prograding into the bay. And then above that, so this is subaerial deposition. And you can see we have a relatively quiet floodplain with organics and some fine grained deposits, mud, silt and clay. And then we get this coarser fraction here, and this relates to the crevasse splay that we could see in the plan form figure. So we dated the crevasse splay deposits, and those are about 800 years old. And you can see really rapid deposition of those, essentially instantaneous within the uncertainty of the OSL ages. And so a couple hundred years elapsed between when the land emerged here from open water, when it was elevated by natural processes, and then ultimately here's the mound sitting on top of it. So people waited a couple hundred years to build here. And we see a similar thing at Grand Caillou. Here we have more information about the mound itself because it was in better condition. And so we've done excavations and radiocarbon dating and recovered various artifacts. We're seeing the mound was constructed about 800 years ago and probably in use until 600 years ago. We didn't find anything younger than 600 years here. And below it, again, we have crevasse splay and natural levee deposits that also aggraded very rapidly. So combined, these things are showing us that both of these mounds were built on rapidly and recently aggraded surfaces, likely recently aggraded for Elsley, and built a couple hundred years after the land emerged in these locations. And another way to look at these same data is on a timeline. So here's a timeline for Lafourche, starting at 1.6 Ka or 400 CE. CE is on the top axis, Ka is on the bottom. And you can see, so the delta starts growing out into the bay. And then at 1,200 years ago, the Lafourche shoreline is near Grand Caillou. At 1,000 years ago, it's near Elsley. And at 800 years ago, Grand Caillou is built, and Elsley may have been built at similar times, certainly after 1,000 years ago. And this pause of a couple hundred years allowed the land surface to aggrade. So here you can see sedimentation time on the x-axis and overbank thickness. And these are showing averages at the different sites we studied for the delta progradation study. And we have a okay, but real correlation here. And so you can see it's allowing a couple meters of sediment to deposit in this time. So changing the environment at this site, both by making it higher elevation, but also the environment is becoming increasingly inland over those couple hundred years because the delta is continuing to build. So the next question we had was, how can our delta growth chronology be extended to understand other prehistoric sites in the delta beyond these two that we've looked at in high resolution? And because we know the time that land emerged here, sites cannot be younger than the land that they sit on. And so this allowed us to refine the ages of other sites, including ones that we didn't look at in high detail. And you can see there are a lot of sites in this landscape where we have earthen or shell prehistoric mounds. And we have the sites classified by their type of material and how many there are. But here's an overview of them. So here's that the linear correlation between age and distance from the sub-delta apex that we see for the growth of Lafourche. And then these triangles are showing the ages of different mound sites that had been estimated before using the relative ceramics chronology. And you can see some of them are realistic. Some of them are after land has emerged at these locations, but a lot of them are not realistic. They're placing the sites at being built or used at a time when it was still open water there. And so we were able to refine the ages in total or create new ages for sites that had never been dated for 36 archaeological sites in Lafourche. And that's important in part because some of these sites can no longer be studied because they've been really disturbed or already lost to coastal subsidence and erosion. And we'll talk about that a little more in a bit. So our next question is, what is the cultural significance of prehistoric archaeological sites, and how does this translate to present-day society and landscape management? And this is work that JR and I have just put together and that we have it submitted right now somewhere. So hopefully it's successful in the long term, but it's the first time that I'm sharing it. So I'm really excited to get to share this with the community. So to answer this question, it's a complicated question. And we looked at 3 different types of information. First, we looked at oral traditions, so the recorded histories of native peoples of the Gulf Coast of the USA, to try to understand the cultural meaning of these places. And then we did 2 quantitative analyses looking at the elevation of the landscape and also the persistence, the time of persistence of the archaeological sites. So we'll start with the oral traditions. The oral traditions that we reviewed that were collected from indigenous peoples of the Gulf Coast revealed a focus on themes of creation, emergence, ethnic identity, and group cohesion. And so these Gulf Coast cultures they're viewing the world as made up of 3 parts. There's the below world, or the primordial waters, and then there's the above world, or the sky vault. And then connecting them is an axis mundi. So this allows connection between the sky vault and the primordial waters. And we wanted to look at how the mounds fit into this, this idea that's shared by many of the Gulf Coast peoples. And so one thing that came up in the oral traditions is this earth diver story, or earth diver myth. And there are several variations of it, but here's one that I'm going to share. This was recorded from the Chinamacha people. And it says, when the earth was first made, the creator of all things placed it under the water. The fish were first created, but when the creator wanted to make men, there was no dry land. Therefore, crawfish was sent down to bring up the earth. He brought up mud in his claws. Immediately it spread out, and the earth appeared above the water. Then the great mystery made men. And so in this case, the crawfish is digging down and pulling up the earth and creating the land that people are living on and using. And this can be related to the creation of mounds as well, when people are manipulating the landscape and building with these soft, malleable sediments in a landscape that is surrounded by water. So it can be interpreted that the mounds are serving as a sort of spiritual component and a way of reenacting these creation myths, that they're an axis mundi in this scenario. We also wanted to look at pragmatic aspects of mound construction, what other positive things these are bringing to the landscape. And so here you can see a map showing the distribution of all the earthen and shell mound sites in the Mississippi Delta related to the timing and different packages of land here. And what I want you to focus on is where some of these sites are. They're sitting on the edge of old terraces here. This Pleistocene area in red is relatively high elevation compared to other things, or along the banks of rivers. Like you can see here along this paleo channel, there are a lot of sites. And so this is showing people are liking high elevation land here, and also land that offers relief. And that's not really surprising. That's a phenomenon that's found worldwide, both in archaeological sites and in present day communities. But there's been very little work that's put values on how much relief is offered and what benefits specifically it gives. And so we wanted to do that for our data set. And so we did this relative relief analysis using LiDAR data that are publicly available for the Mississippi Delta. So here, for example, in this panel D, you can see one of the mounds that's showing up in LiDAR. And we looked at a couple of things. We looked at the elevation at the mound tops when that information was available, and then we truthed that to written records of the mound elevations, because sometimes LiDAR processing clips things. And then we also looked at the elevation of the natural landscape immediately adjacent to the mound. And then we looked at the average elevation of this whole Lafourche Sub-Delta for which data were available for the LiDAR, for the part that was built through progradation in open water. And then we also looked at average elevations of the 1 square kilometer area around the mounds and the 25 square kilometer area around the mounds, which is what you can see here. And by doing that, 1 square kilometers is roughly the view shed, what you can see from a mound. And the 25 square kilometer area is what's been previously estimated to be the travel distance of the people who would have built this. So it's giving us a sense of how people interacted with their environment and what was available to them from these sites that they selected to build monuments on. These are the data from those analyses. So we have 3 plots, and they all have distance from the delta apex on the x-axis. And then this first one has absolute elevation on the y-axis. The others have relief, calculated as relative relief, so the difference between 2 elevations. And here, let's look into the first one first here. So we're looking at different types of mounds as well. Earthen mounds, shown as the brown circles, versus shell mounds, which are shown as the blue squares. And then whether the mounds still exist today or whether they've been destroyed, indicated persisting mounds are solid and ones that no longer exist are open. And then here we also have this bar in this figure. The red line is showing the average site adjacent land surface, so the natural land surface next to the archaeological sites. The yellowish orange line is showing the average 1 square kilometer viewshed of the sites. The green line is showing the 25 square kilometer daily travel range. I did not show the Lafourche elevation on here because it's 0.45 meters, so it falls right in here as well and is essentially obscured by the other data. And then you have the mean sea level here. So we're seeing the average elevation 0.45. The mounds can add up to 6 meters of relief on top of that, so making this landscape really different in that one point. And we found that the mound locations are about 30 centimeters above the 1 square kilometer viewshed. So you can see that in the second figure here, and that they are about 0.4 meters or 40 centimeters above the 25 square kilometer daily travel range on average again. So the similar viewsheds, travel range, and average bayhead delta elevations suggest that by selecting these sites, people were intentionally building on relatively high elevation land, but they still had access to all these different resources of the delta that can be found at diverse places in the delta, or heterogeneous places. So high elevation resources, low elevation resources. The mounds were resource rich while still being relatively protected from flooding and desirable habitats in that sense. We also saw, so I was really surprised to look at these data because there aren't really any trends with distance, and there aren't any trends with persistence either for the different types of mound construction. So it was one of the more trendless data sets I've made. And I looked at that for a minute and thought, well, then there must be other factors in whether or not these mounds persist today. And so that's the next step of the analysis. It's a busy figure, but I'll talk you through it. So here we have a timeline for Lafourche initiating at 400 CE and going up to 2000. And these are all the different archaeological sites that we looked at. This is when they may have first been constructed, the maximum age or the terminus post quem, essentially determined by the land emergence at those sites. And then this is the likely age where we're correcting for that couple 100-year offset that we saw at the 2 sites between land emergence and sufficient aggradation for people to want to build there. And so they're arranged upstream to downstream. These are inland, these are coastward. And then they persist for a very long time. The solid lines are when they're recorded to persist. And then here you can see the shading indicates when the mounds were first disturbed or destroyed. When they're completely destroyed, the line ends. The ones we were able to verify still persisting in some form today, we have an arrow for. And the ones where the condition was not well known or recorded, we have dashed lines. So what you can see is that a lot of these no longer exist, right? And many of them have been disturbed or destroyed very recently, based on looking at the archives that were available and the mounds for which there were data. And then we've also color-coded this to show what disturbed or destroyed the mounds. And in some cases, it was more than one thing that was recorded to do this. But you can see a couple trends. So for example, green is agriculture. And you can see green and agriculture are important in the upstream locations. And then once we get more coastward, we start to see erosion or subsidence playing a factor, and that's shown in blue. And then industry becomes very important as we move coastward as well. So that's shown in red. So this is combined showing that archaeological sites have persisted for centuries, yet undergone rapid destruction and loss in the last 100 years. And that corresponds to the loss that we've seen in the Delta landscape in terms of just land area as well. And then these are places of high value to people. We talked about the cultural significance to native peoples. And then they're also used, for example, here as these intrusive cemeteries. People build houses on top of them. They're places that get reused over and over again. So they sort of transcend both time and culture in this sense. Archaeological sites have also been considered to be ecological islands, and this is something that's been studied by others. So for example, here you can see this mound that's near the coast. Around it, it's all wetland grass, right? But the mound is creating a supporting matrix for trees to grow on it, and you can see these oak trees. So we have different types of plants in these different elevation sites, and that can also support different animals. So increasing the heterogeneity of the landscape and the ecological diversity. When we combine this all together, we can see that the mounds are ecologically significant, they're culturally significant, and they add to landscape heterogeneity and are a part of the landscape. And then finally, we can bring this into the fourth dimension and say that these are things that have persisted across time. And so all combined, we view these archaeological sites as keystone landforms that are contributing to resilience in this setting. And for this reason, it's important to study them, to try to extract knowledge from them, to preserve them when it's possible, and when it's not, to try to do triage and learn as much as possible before they're lost. On that note, and to wrap things up, $50 billion have been dedicated to coastal restoration in Louisiana, but there aren't many resources yet that are committed specifically to archaeological sites. And I think that's something that could be important in the future. So what does this all mean when we look at it all together? Well, and in the context of this changing delta. The takeaway points that I hope you got today are that the management of sedimentary systems requires human perspectives and values in addition to fundamental geoscience. Both are important. And archaeological sites provide a millennial timescale record of human adaptation to environmental change. And so when combined with non-Western perspectives, this information and these viewpoints can help to inspire approaches for landscape management that may work with nature and may be sustainable. So in summary, this is the last real slide of my talk, and I'm going to ask you to do an interactive quiz. So the question is, in the context of human adaptation to environmental change, is JR A, preparing for sea level rise, B, giving a lecture online, C, all of the above, or D, other? And if you select other, please write your other in the comments. So now we'll go to this Slido, and you can scan the barcode, I believe, and then enter your response in the quiz. And with that, I'll conclude my talk. I'll leave this slide up, and I look forward to seeing how this quiz pans out as I answer any questions you have. Thank you.
Thank you for the talk. This is very interesting. So I would tell everyone to actually vote your answers. And the chat is also open. If you have any questions, you can write them in the chat box and I'll read it out.
Should I exit the screen share and go back to?
No, okay. No, you might need your slides to answer some of the questions. Okay. Maybe you can just keep it shared. It's fine. May I ask a question in between, since there's no questions in the chat box yet? So some of the archaeological artifacts that were excavated or unearthed were the ceramic pots. So couldn't those be dated too? So then you could correlate it with the deltaic age.
Yeah, it's a good question. We can use, it used to be TL was used a lot. Thermoluminescence was used for dating ceramics like that. And now we've switched to more using OSL for that too. And so it's something we could do for them. But in this case, we found enough radiocarbon datable material, so organic material. And radiocarbon's a lot cheaper than OSL. So we did that. If we're in a scenario where we want to know more about the specific pot, or for example, if we want to try to better refine this ceramic typology that's used as relative dating, then OSL dating the pots would be really valuable.
Mm-hmm.
Yeah, thanks for your question. Well, it looks like all of the above is winning out in the question of what JR is doing. I'm gonna, if anybody needs inspiration for a minute, I'm gonna go back to the slide and you can look at it and vote, and then we'll go check in on the results again.
There's a comment by David McDonnell. He's commenting that he's practicing a surfing form. Obviously, he doesn't get out much. So which is in response to the question that you asked about Jair.
Yeah, let me pull this over and see. I think I was kind of out of the loop on the chat for a minute, so let me get oriented.
So I'll read in the questions too. So there is a question by Mark Hawson. He asks if there were some archaeological sites that were used multiple times.
Oh, yeah. So we only did the really high resolution chronology at the one site, and we saw that it was we only recovered things that were used for up to 200 years. But that doesn't mean that it wasn't used. It can be really hard to date abandonment because you're essentially looking at a lack of a record at that point. The sites are still used today by some people. So some indigenous people, for example, of the Homa Nation of Lafourche Parish and Terrebonne Parish in South Louisiana, feel connected to it and are still stewards of those sites too. But I don't know if people like moved in and out within the time. More of what we saw in this case was that people would use the sites, and then we think that they were largely abandoned when the river shifted courses and the environment became less favorable.
Mm-hmm. Sure. Okay, so there's another question by Stephen from Wales. So he thanks you for your great multidisciplinary talk. And he asks you, during an relative sea level rise scenario, do you see any of these features as possible protecting area as positive feedbacks?
Possible protecting areas. So if I understand, it's asking if they can serve as a buffer for things like storm surge, or if they can help keep pace with sea level rise for the vegetation.
Probably both, or maybe mostly due to the change in the sea level. So
I'm sorry, I don't understand.
Yes, as a buffer. So
yeah, I think that so for example, we looked at Lafourche, right? And there's only 36 sites there, and a handful of them are outside the levees. Others are within the levees. And they're ultimately not very large things, right? They're at most maybe 20 meters across. So I think as a whole, they're not going to provide a lot of a buffer to protect modern coastal communities, but they are really important for fostering ecologic biodiversity in the area. So because they're a different elevation, they support different types of life there. And that can be an important aspect of systems as a whole adapting to environmental change, having ecosystem diversity or heterogeneity within a landscape. So in that sense, I think they could be helpful, but overall, I don't think they're going to serve as an immediate storm buffer.
Okay.
Yeah, but thank you for that question.
All right, so we have the next question from Valentine. So he says, super cool to see research like yours building bridges between different science realms. My question to you, in your research with the natives, did you hear stories about hurricanes as well?
About hurricanes?
If it's out of topic.
Yeah, I believe there are stories about that, but that wasn't the focus of the review that we did for this study. So I think JR has done some other work on things like that. But for our study, we really restricted our review of the oral histories to looking at stories that related to creation, emergence, and group identity in this case. and really specifically things that could be related to the landscape and the use of it.
All right. So the next question is from Jaco from Wales. Nice different angle on sedimentology. How can sedimentologists contribute to the type of research you present in ways that you cannot do yet?
Well, ways that sedimentologists can contribute to interdisciplinary research, I think.
Probably that.
I'm sorry, what?
Yeah, it's probably that. So how can you contribute to the type of interdisciplinary research?
Yeah. Well, contributing things like in this case, JR and I got involved in working together because I could contribute the chronology to it. So really, initially my role was looking at chronology and delta evolution. And then I learned a lot from him as I started working with him. He's still very much the expert on the human component of things, but I think, yeah, attending talks at conferences that are outside of your expertise, listening to colleagues from other departments in your university, and you'll see overlap, I think. And then when you see it, you can think of ways that your science can contribute to the projects that are ongoing in other areas. So in this case, I didn't know that there were prehistoric archaeological sites in Louisiana up until I talked to JR. And I'd worked in the Delta as a geoscientist for a couple of years at that point in these specific areas that we studied for the work that I showed today. And I just didn't even know that this was there. So listening to other colleagues who do different things can be a nice way to get into interdisciplinary stuff.
All right, so we have some more questions. So Ross from Canada thanks you for your wonderful talk, and he asks: Are any traditional oral traditions preserved about where mounds should be built and when they should be abandoned? So he has seen some research from New Zealand on traditional stories which guide land use near a river that floods often.
Yeah, it's a really good question, and I think it applies not just to these kind of prehistoric sites, but also to present day things, right? Like, when does the environment become untenable to the point where it's cheaper, safer, or easier to relocate? I am not aware of any oral traditions about that for the Gulf Coast. And I think even in present day society, I don't think we've quite gotten that figured out for Louisiana yet either. But it's something that would be really nice to know.
Okay, so there's another comment by David. He says that he really loved your presentation and it's a great integrative work. Very well presented. Well, Stephen has a question again.
Okay.
Okay, so the reason for his question was that in the shallow angle tropical shorelines, we often see areas of even small limited relief becoming areas with preferential plant growth that then feedbacks to become other areas of preferential sediment accumulation.
Okay, yeah, I see. Yeah, in that case, it could be valuable, I think. And there has been some work on wetland creation and preservation of the mounds that JR and other colleagues have led. So it's a small scale thing because there just aren't that many of these specific mounds compared to other features in the Delta, and the mounds aren't that big. But yeah, I think supporting the wetland matrix even at one site can be helpful.
Right. So you have another question from Patrick, Germany.
I just saw a question asking if indigenous people had crawfish boils.
People had crawfish boils.
Yeah. You know, they actually ate a lot of the Rangia cuneata, the shells that we find in the mounds sometimes. And these are small bivalves and with very thick shells. So you really have to peel a lot of them to eat them. And some of the archaeologists have tasted them today because these still live there and exist there. And apparently they taste horrible.
Okay.
Okay. So sorry, I skipped Patrick's
question.
So
that's a question from Patrick, Germany. His question is there any pattern between the coastline change and the archaeological settlement dynamics?
Yeah, and so what we see overall very broadly is that people like to live in the active portion of the delta. So I talked about how the river moves with time. When the river is occupying a place, people like to be near that active part of the delta. And then it seems like as the river moves away from that, when it avulses to another location, people don't want to live in that area as much anymore. Like once the river avulses, people tend to move to the new location of the river. And one potential reason for this, well, there's a couple potential reasons. One could be things like saltwater intrusion. So as the fresh water coming down the river stops, more of the salt water creeps in from the coast, and that can really change the environment.
Mm-hmm.
And what type of resources are available for food, for constructing homes, all of that.
All right, so there's a question, can we get an update on the results of the
Yes, excellent question. Let's go check on it and see. And I saw somebody had written in a comment, I think, about geosurfing too. So we got one right in. Let me see what that was. Practicing his surfing, but he doesn't get much. Okay, let me see if I can get back here. And oh, all of the above is winning. It looks like this poll, 9 people responded. Others think he's preparing for sea level rise, was the second option.
Mm-hmm.
All right.
All right, so I don't see any more questions in the chat. If you're not busy, can I ask you one more question?
Yeah,
are there
sure.
any evidences of storm surges or hurricanes in the areas that you sampled or areas that you studied?
Yeah, so the 2 sites that we looked at in detail for this study are both inside the levee, but you know that Louisiana was hit by Hurricane Ida this autumn, right? And so there was a really recent and very strong modern storm there that the communities in Lafourche and Terrebonne parishes and other places are still trying to recover from. And so some of the sites here are also outside the levee, and I don't know how they fared.
Okay, all right.
Yeah.
All right, so if okay, so there's another comment where shorts is equal to sea level rise. It's obvious.
Yeah.
So pretty good comments coming.
Sea level rise and adapting to the online format are all human adaptation to environmental change.
True. Yeah. All right, so I don't see any more questions, so I think we can wrap up pretty much now. So before we go, I would like to thank everyone. I would first like to thank you for your wonderful talk, and then I would also like to thank everyone for joining and listening to the talk. And don't forget to join us next Wednesday, where John Reijmer will discuss on the marine carbonate factories, their sedimentation patterns and sequence stratigraphy. So I hope to see you all there. Thank you for joining.